So in this case, we're looking specifically at the telco industry, and we've moved away from port generation to more of the style of data analysis and machine learning. So here we're really going to start to see how we can combine both the generative AI aspects of prompting with predictive AI, which is all about building machine learning models. So here to set the scene, we have a telco AI customer retention analyst, or at least the workflow diagram for such. So starting at the left, we can see what data we're actually giving our agent. So here we have some churn data. We have a customer profile. In that data, we also have services and financial data. All of that is going to be given to H2oGPTe agents, where it has access to a few tools. So the first being Python coding. We can also use H2O driverless AI, and finally, advanced reasoning. So that's where, again, we might use OpenAI's GPT-o1, for example, for planning and validating the methodology of our agent. And then finally, the output from our machine learning model can then be synthesized into insights such as recommendations. There might also be key findings. And as well, our agent can extract visualizations from the machine learning model. And all of this is to essentially make sure that we're generating recommendations for reducing churn. So that's the goal of this agent in particular. So again, I'm going to go back to H2oGPTe. I'm going to show our prompts and then again how to launch our agent from there. So I'm back in H2oGPTe and I've put my prompts in already. And the first thing to do is to validate a prompt just to make sure that we're doing all the right things. So again, we've set up the context. So we're giving the AI the persona of an analytics agent, specializing in customer retention analysis. And our task is to analyze the following telco customer churn data, and we give it some customer attributes. So for example, the customer profile, so demographics, maybe even some tenure information, so service subscriptions, billing information, and we're also informing the agent that our target variable is churn. Okay, so then now we're also describing to agent what analysis tasks it should take. So from data preparation to analyzing the customer's profile, service usage patterns, and financial analysis. And finally, we have set out some output requirements. So we want statistical summaries of key relationships, risk factors ranked by importance, segment-specific retention strategies, as well as visualizations and the projected financial impact of recommended interventions. And then finally, of course, we want to provide a data set link. So this is the link to our data. I've also instructed the AI agent to use H2O driverless AI for all modeling. So now that we've set up our prompt, we can go ahead and launch our agent. So the way we do that is by clicking Use Agent, and then we can also customize our agent by going into Configuration. And one thing to note here is that we have our H2O driverless AI data science tool here enabled. For the moment, I'm going to leave everything as is. I'm going to close that tab and submit. So we've launched the AI agent, and we can see already that the AI agent is in the process of starting. So we'll wait a moment to let it start. So we can see that it's already going ahead and trying to download the data. And at the top, we can also see that H2O driverless AI is being used to construct some models of sorts. And as well on the right-hand side, we can see that some sources are used. So from there, we can see that the data was pulled correctly. So we're up to step two. This could take a while. So what I'm going to do is wait a while and come back and show the final result. Okay, so we have the final product now from the AI agent, and we can see it's what looks like has displayed a few charts. So off the bat, we can see that this one at least looks at churn probability by certain groups. So here it has by contract type, by tenure group. This one's by number of services. And then here at the bottom right, this is what looks like monthly charges versus tenure. We also have a few other charts here. So this one is variable importance. So which variable is the most important from our driverless AI model? And also some metrics. And then finally here, we also have a lot of detailed information. So first is the model performance. We have some key risk factors ranked by impact. the customer lifetime value by segment, service impact analysis even. There's also an implementation roadmap here, so some recommendations for reducing churn at the organization and as well the expected impact. So more recommendations here as well, but it's also generated some key files that we could look into. So the first being visualizations of churn patterns, feature importances, and model performance metrics, which I assume are very similar to these charts here. And finally, if I was wondering where exactly the agents actually generated this code, where they stored this data, we can see even more information in the downloadable files section here. So for example, here there are some interesting charts that we could look at. This one maybe is risk analysis, so risk score distribution by contract type and billing method. So this one looks like a bit of a intermediate chart that was generated. We can also take a look at some code. So this one is for creating summary visualizations, so we can validate that this is all correct. So at the moment, I'm happy with what the model has generated. I could even go ahead and ask the model to maybe expand on its implementation roadmap. And from the models here and from the overall analysis that it's done, generate a more extensive report similar to what we had done, for example, with our government and financial agents. And I can do all of that from the prompt bar here, so I can type in all of my improvements and the agent can go ahead and make those improvements and return back with its results. So for the moment, I'm happy with what's here. What we're going to do next is move on to our final use case. And again, this is going to be in a different industry. So again, a slight twist to what we have now. So we're going to jump back to the slides in a moment.